Ganesh Kumar Mukhara.
Hi Ganesh.
Hi.
I'm Ganesh Kumar. Currently, I'm working as a admin, SaaS admin. I have three plus years of experience. So I already learned Spark and everything. I want to learn AWS tools like Lambda, EMR, Redshift, Athena, and the Glue. These things.
Okay, thank you. And Harish?
Hi everyone. My name is Harish. I have a 5 years experience in ETL. So I would like to move ETL to data engineer side. So that's why I'm looking forward to go with this course.
Okay, thank you. And Mallikarjun?
Hi all, myself Mallikarjun. I have total 5 years of experience in IT industry, and at present I am working as a ETL developer. The tool which I was using is Talent, so I want to upgrade my skills to the AWS side. So because of that, I was here. Thank you.
Thank you, Mallikarjun. And Salva? Oh, Salva, you can unmute yourself and speak.
Hello, hi.
Yes, please.
Hi, hello, hi everyone. I'm Selvavel. I'm support engineer in TCS. 1.5 years of experience. I'm looking to move data engineer in AWS to upskill my career. Thank you.
Okay. Sneha?
Hi everyone, I'm Sneha Shukla. I have been working as a people analytics professional and I have experience of around 6+ years. And I want to improve my skill set so that I can be a data engineer. So that's why I'm here to attend this course.
Thank you, Sneha. Yeah, Aditya, we can go ahead.
Okay, thanks everyone for your brief intro. This really helps me understand the overall audience. Very good evening. My name is Aditya. I am working as a senior data engineer and ML engineer within my current organization. I have experience of 8 years, mainly into the data aspects of it. I've started as a ETL developer using Informatica and then gradually moved into cloud aspects. And now I am doing ML engineering, building data science model, and data engineering is my forte. So that's a very basic about me. I welcome you all to the first demo session of this course. I hope this session will be informative enough and engaging. So with that, let me share my screen. Okay, I'm sharing my screen. Let me know if my screen is visible to everyone.
Yes.
Yes.
Thank you so much for the confirmations. So guys, this course that we are about to discuss today is AWS data engineering, right? So it has two components. One is AWS and one is data engineering, right? So first, let's address what is data engineering in general, right? And then we'll address what exactly AWS is, right? So first of all, what is data engineering, right? So if we have to break this word down, one is data and one is engineer or engineering, right? So we know data is growing at each and every day, right? So if we see the amount of data that was being produced 10 years back, maybe in year 2012 or 13, and if we compare the amount of data that is being generated today, there is a massive shift in the data. And you can see this from yourself. Let's take an example of social media. So back in 2011, 2012, there is a very little exposure of social media, right? However, as of today, everything is being driven through social media. And we know the amount of data we generate on social media. So there is a stat published by Statista. So the stat says the amount of data that is being generated back in 2010 within a year, the full year, is equivalent to the amount of data that we generate today within a day itself. So you can see the shift of data which is being generated every day, right? And everyone knows data is the new gold in this era. So the question is how organizations, how company tap into this data, how they use this data to make meaningful decisions so that it eventually helps them grow their business, generate more profits, build more revenue, and overall make them profitable, right? So it's data is everywhere. The only thing is how to tap into it and make more money, right? So therefore, there is a desire need to manage this data, extract this data, process this data, generate meaningful information out of this data, and hence the concept of data engineering emerges. It's not a old concept, it's a very new concept that has been in the buzz from last, say, 5 years, if I'm not mistaken. So this is what data engineer or data engineering is all about in a nutshell. They are responsible for extracting the data, managing the data, handling the data in a way, and eventually generate meaningful information out of it, right? Just to give an example of what is a meaning of meaningful information, how business take data-driven decisions, we'll take one example. Let's say there is a food chain business. So they have food chains in various places of our country, or say, outside our country as well, right? So every day they have plethora of customers that come to their stores. They buy products from their store. So eventually what is happening? So whenever a customer is coming to their store, they are buying some products, they're getting information about, customer and definitely the buying habits of customer, right? So if this customer comes, the customer buy one burger with a Coke, some customer buys one pizza and whatnot. So every day the amount of data is being gathered, right? The company is collecting this data. Now, how they can use this data to generate meaningful information. Let's say company wants to open new stores in some tier 2 or tier 3 cities, right? So how they can utilize this data? They can see this data and understand what is the most demanding product for them. And if the customer comes from a far away location to buy that product, how they can know? By using their personal information like their PIN codes, their addresses, and so on. Accordingly, they can make a cohort of PIN codes and decide what would be the best suitable location for us so that they can open the new store and generate more profits. So what they have done, they have just collected raw data, build data analysis, generate raw information into meaningful insights, and using that, launch a new store in a location that can be a hot cake for them and which can earn more profit for them. Right? This is just a one basic example of data. There are various use cases of data in real time, in streamings, in social media, whatever we do, everything is now being data driven, right? So with that, I'll quickly jump on to the next part, what exactly AWS is doing here, right? So AWS is nothing but Amazon Web Services. It is a cloud provider which enables us to run data engineering on top of the data that we have, right? Having said that, I'll quickly move on to my first slide of data engineering. So here in detail, we have explained about what exactly data engineering is all about, right? So data engineering in nutshell is building and maintaining the infrastructure, or you can say pipelines, that can handle the large scale or fast moving streaming data with which you can process, transform, and generate meaningful insights out of it, right? So this is basically data engineering in a very nutshell all about, right? So we'll see data engineering, the various aspects of it as we move along in our sessions, right? And then what are the basic responsibility of data engineers is, right? So they are responsible of extracting data from various sources. Source can be a file, source can be a database, source can be a streaming platform, source can be a social media platform, XYZ, right? What they do, apart from that, they are responsible of transforming the data. When I say transformation, meaning the data in a shape so that data analysis, data science can be run on top of it. And how they do that? By building data pipelines, right? So this is the basic responsibilities of data engineer. So if a company has to run data science model, if a company has to run ML engineering, if a company has to produce data-driven decisions, they need data in a right format, right shape, and data engineers are the key person that enables them to produce this data so that insights can be generated out of it. So you can see from this perspective how important data and data engineers are in this world. And this is going to grow massively in upcoming years as well, because data is also growing at a rampant speed in this world, right? Why its importance, right? I already mentioned that because with the help of data, you can take data-driven decisions that can impact business in massive ways, right? With the help of data science, with the help of machine learnings and all, people can take more data-driven decisions which can impact their business in big time. Now, as a data engineer, I talked about all the positive things, but what challenges data engineer can face in a day-to-day life is how they can build scalable data platforms that handles small scale as well as large volume of data altogether. Moreover, how to put governance, how to handle real time and streaming data, and how they can manage data versioning. Guys, just give me a 1 minute. Sorry about that. Yeah. Then how exactly data engineers process the data? So with the help of cloud, with the help of various ETL tools, say Informatica, say AWS Glue, Lambda, how or where we store the data. So we store the data in Redshift, right? How we automate the process with the help of Airflow DAGs and so on. So all of this will be covered in detail with hands-on experience and industry standards, coding practices and everything as we move along in our sessions going forward, right? So with that, I'll quickly move on to next slide where we talked about what exactly cloud is, right? Because everything is now moving to cloud. So what cloud means for us. So whatever picture you are seeing with this cross arrow is actually not a cloud that we are going to learn, right? So the cloud that we are going to learn is an image which is present with this green border, right? So what exactly cloud is? Cloud is nothing but a collection of various servers placed in a secure location far away from the reach of customers. It is highly maintained, highly secured, 24/7 available servers with which I can store my data. I can compute my data without any issue of security, maintenance, and so on, right? There is a picture on my right-hand side, which quickly talks about the quick stats of how many cloud providers are available in the market and how their market share is. So this report is being published by Statista. Statista is one of the leading organization that collects the data and publishes these kind of report. So back in 2023, AWS has been leading the market, and you can see from the graph as well, followed by Azure, followed by GCP and few other clouds. And this has been grown massively in this years as well, right? So I don't have a right number for today, but AWS has leading the market, and hence this course is completely being designed on AWS cloud tech stack altogether, right? So let's quickly talk about what is the need of cloud and what exactly cloud is. So before moving to the need of cloud, I'll give you one example that you all can relate what exactly cloud is, right? So I hope everyone has used Google Drive in one way or the other in their life, right? Can anyone confirm, or is there anyone who has not used Google Drive in their life? Yes, no, maybe. Guys, you can unmute yourself and speak.
No, we have all used actually. I mean, I know I was using daily. I mean, so I am storing all my pics, everything in the Google Drive, everything, right?
Even I used it.
Okay, so I hope that everyone in this generation, right, has used Google Drive. And this is one of the basic example of cloud. So what Google Drive is, it's a cloud platform where you can store your personal information safe and secure, right? So what it enables you, you store some data on the cloud, and once the data has been successfully stored in the cloud, You can use it from anywhere. The only thing you need is internet. And second, your user ID and password, right? So if you need, if you have these two things, you should be able to access this information from any part of the world without any worry. And also there is no worry of losing this data. If let's say there are a few photos stored in your mobile phone, if it has been stolen or damaged, those photos are gone. But had been these same photos or whatever information has been uploaded to Google Drive, it will be there forever until you explicitly delete them, right? Which means that you have access to this information infinitely, right? So this is one of the basic example of cloud that everyone has used, everyone has touched in their day-to-day life. And what AWS gives is a very high level version of the same cloud, but uses the same principle, right? I hope now the basic intro of cloud is clear, like what exactly cloud is. Now let's see what exactly AWS cloud is all about, right? Since we have a basic understanding of what cloud is. So what AWS does is, right, I'll talk about from a history standpoint. So AWS started back in 2006, 2007. They came up with the same approach of storing the data, the way Google Drive store. They gives you the service with the services called S3 buckets. So in S3 bucket, you can store your data, right? And it is being stored over there. You can transfer the data with the help of internet, right? The way we do for Google Drives. Once it has been stored in S3 buckets, it will be there forever until you explicitly delete them, which means that you can access this data from anywhere, right? So this is a very basic example of AWS cloud services that they have started with. Now, today in 2024, they have more than 400 plus such services available in the market that everyone uses to process the data. Before talking about those services, let's see from an example standpoint how AWS cloud computing benefit each and every individual and why everyone is rushing towards cloud, leaving the on-premise stuff, right? So let's first understand from a basic example. Okay, so let's imagine you are going, you are planning a trip to a different country, right? This trip is going to last about 15 odd or 1 month in general. And as part of the trip, you have decided that you will travel to 3 different places. And for traveling these 2, 3 different places, you decided to drive a car in that area, right? So there are two things or two options that can occur. One option is you can buy a car in that country, right? Of course, you have to pay the full price. Then you have to worry about the insurance stuff. You have to worry about the registration stuff and the taxes that you have to pay for that country, right? You will drive the car for sure for 1 month, and after that, you cannot take the car back to your, country, which is India for us. You have to leave the car over there, which is the option number one. Option number two is there is a renting company in the same country. What they say is you can rent my car. You have to pay only the price for the days you are driving the car. You need not to worry about insurance. You need not to worry about the taxes. You need not to worry about the registration and all. They will take care of. You only need to pay the price for the number of days you are driving the car. So guys, tell me, honestly, which option will you be choosing if you have to, plan the trip?
Rent a car and the second option.
Correct. What about others? What your approaches will be?
Second option.
Okay. Why second option? Can anyone tell me? Like in common sense, like why we are choosing second option? Yes, second option should be the right option, but why?
We can use whenever we require, I mean, how much we require, and later
Correct.
on, if we not required, then we can stop there itself and we can come back to our own. And that's the main thing which I was thinking.
Correct. Correct. Which means that there is no headache for us to pay the full price of buying the car. We are
And
only paying.
maintenance. Yeah.
Yeah, we are just only paying for the time we are using. There is no headache for insurance, no headache for taxes. Let's say if car got damaged, it's something the car company will take care of. We need not to
Correct.
manage, right? So therefore, it's a less headache for us from a
Yes.
basic travel standpoint.
Correct.
Same thing, same logic has been applied in the world of cloud computing as well, right? So what organizations were doing earlier before the cloud comes into place, they were having data, they were having processes, they were generating the meaningful insights out of the data as well before the cloud came into picture. But how they were doing? They were having the on-premise servers. When I say on-premise server, it means that a server like this, they have to maintain on their own within the company, right? So to maintain these servers, they have to hire a lot of people who have expertise in maintaining these servers, right? And these servers have the tendency to get heat quickly. So they need to also take care about the maintenance of the heat as well, how they can cool these servers off, right? And after 2, 3 years, normally a server needs to be replaced because that's the basic age of a server in general, right? So these are the basic things that a company or organization has to do. They have to store data within the company provided servers. Let's say they are maintaining a database. So they have to buy a server, build a database on top of it, they store the data over there. If anyone has played a database admin role, DBA, they know what painful activities to maintain these kind of stuff in-house, right? That's just one thing. Second thing is, let's say there is a demand, of processing the data quickly. And for that, they need special type of servers. Let's imagine you have a 16 GB RAM computer, and there is a requirement that for running this application, you need a 64 GB RAM computer, right? So what you will do, either you will buy additional RAM, or either you will replace with a new computer with better RAM. For that, you have to pay a lot of money, right? Same thing organizations have to do. If they have to run a high compute analysis, they need to buy bigger servers. For that, they have to pay a lot of money, right? And they have to hire a lot of people. They have to take all of headaches just to run a quick analysis. And let's say this analysis only ran for 1 month or 2 months. It was a mini small project. Then after 2 months, what they will do with these servers, what they will do with the team, they cannot directly sell off. If they sell off, they will get only half the price because this will be sold in the second hand category style, right? So it's become a pain point for them. If they have to run any analysis, they have to think twice. Okay, whether it's a wise decision to buy a server, it's a loss costly, blah, 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 right? So what an alternative AWS provides is, what AWS say, hey guys, I have a very huge server. Come to me. You want to run analysis for 1 month? Okay, pay me only the price of 1 month, nothing more. No penny extra than that. Pay me per second. Let's say if you are using my server for 29 days and 23 hours, 58 minutes, 59 seconds, pay only that price. Even you don't have to pay 30 days money. Pay that price only. Use my servers. Whenever you are done, go. No extra cost involved. And this gives organization a quick way of analyzing, managing, producing the data without any headache of managing the servers. And this allow organization to quickly process the data. And this gives them an advantage. And hence, everyone is shifting towards cloud. They are dumping their on-premise servers. And guys, I'll tell you, lot of project you will see in the space where there is a migration going on. And this migration is about moving the existing setup from their on-premise servers to cloud. Why? Because cloud is cheap, cloud is more effective, there is no downtime, there is no maintenance cost. Every headache is of AWS itself. They only need to buy, or I would say rent for the time they are being using it, and that's it. And that's why there's a rush to move towards cloud computing, right? So this is basically about why everyone is going toward cloud computing, and AWS is leader in this space, and hence you will see lot of openings with respect to AWS engineer or AWS cloud computing data engineers, right? Any doubt before I move on to the next slide so far?
Nothing from my end.
Okay, what about others?
No doubt.
Awesome.
No doubts.
Awesome. Thank you so much. Okay, so now I'll quickly talk about what we are going to cover in our sessions, right? What all this course contains, right? So these are the basic list of topics that we are going to cover as part of our session, right? So we will cover basics of SQL and Python. We will cover AWS services like S3, Lambda, Kinesis, Redshift, Glue, Athena, right? We will go deep dive into PySpark, which is used to handle big data. So basically, in simpler words, we will talk about big data and its processing as well. Moreover, we will discuss batch processing, real-time streaming processing. Apart from that, we are going to discuss the real-time projects that runs and used in industries. And guys, cherry on top of the cake, every topic is going to be hands-on. There is very minimal theory involved. Everything is down to the precise coding standards that are being followed in industry, the best practices that are being followed in industry. Every topic will be discussed in that fashion. And once we discuss a topic, we'll also discuss the question that can be asked to these topics in our interviews as well, right? So this all will be covered with all of these topics. If I have to talk about in details, like what are the different things that we can cover as part of this topic, here is a list. I think Ganesh can share the curriculum with you guys. So I am not going to spend more time like what all in detail things we are going to cover. But in a nutshell, this is what we are going to cover. Apart from that, real-time projects. Apart from that, I have a bonus that will talk about Airflow as well, right? Okay. So any questions so far, guys, before I jump on to my next presentation?
I have one question.
Yeah, please.
Hi, this is Pinak here.
Hi.
So I would like to know that for AWS, the services which we will be doing in the course, how we will be going to launch them. I mean, whether we'll be using AWS CLI or whether we'll be using GUI.
Okay, very good question. So there are multiple ways to launch AWS service. One is, as you mentioned,
Yeah.
graphic user interface, which is called UI. It's the benefit of everyone. Second one, you mentioned CLI. CLI means command line interface. Guys, so basically it's very similar to CMD in Windows or in Unix or server, where you can write some scripts and it will launch the services. Third way is using cloud formation templates, right? Which is the third service, which has been used in majority. So normally for quick learning purpose, I launch the service using GUI, but I also talk about how to launch the same service through CloudFormation template, because that is the industry standards which has been followed across various organizations. I hope this
Got it.
this answers the question. Yeah. Any question, guys?
Yes, yes.
Any other question, guys, before I jump on to the presentation?
Aditya, how many real-time projects would be there?
So I will cover two real-time projects. One is for batch processing and one is for streaming.
Okay, thank you.
Yeah.
So Kinesis, is it same like Kafka or is there any difference?
In principle, it is same, but if you talk about the usability, the coding standards, how they are being used, so there is a difference. But in principle, the use case, Kinesis, Kafka, same.
And what are the programming language it supports?
Python, Java. I'm aware of these two. I have to check what all others it has support. And guys, the whole course will be based out of Python language, because this is the language that data engineers uses predominantly in the industry, and it is one of the easiest language to practice with. So we are going to use Python throughout our course.
And this glue is like Airflow or something different. What is
So
glue?
Glue is a ETL tool. If somebody has used Informatica, Tailend, Uzi, so Glue is very similar to that. So it's a ETL tool where you can write a script or use drag and drop to build your ETL pipelines. ETL is nothing but extract, transform, and load. You can extract data, transform it, and load it back to a target.
So we have a Spark for transforming data, right?
Right. Absolutely right.
Yeah, but what is the difference between Glue and Spark? Like even Glue will transform the data, but is it only limited for a small amount of data, or how it will
Very
be?
good, very good question. Right. It's a very good question. Thank you for asking. So Glue, as I mentioned, is a drag and drop service, but in the backend, Glue uses the capabilities of parallel processing, which means PySpark or Spark. So from the outside, for us as a developer, it is a drag and drop, but in the backend, what it does, it utilizes the concept of Spark to process the data, which means that it can handle small data as well as it can handle large scale data as well.
So in which cases we'll suppose for ETL jobs, some jobs we can automate by using the glue, right? We can
Correct.
extract and transform and load. For some jobs, we'll extract from the sources by using Scoop, Spark, and
Correct.
transform it by using Spark and load it using Spark only. So
Correct.
in which case we'll go with this way, and in which case we'll go with glue.
Very good question again. I would like to explain this question, and this will take me at least 1 hour to explain in detail. But if I have to give a small answer, considering the time constraint for everyone, so Glue enables us to drag and drop. However, Spark, you have to code. So think of a person who is just moving into data engineering space, know a little about coding. So which tool or technology the person used will prefer to use a tool where only some small coding is required, or a tool where everything needs to be done in coding. So this is a very basic difference between Glue and Spark, but there are more differences that we can talk about as we move along in our sessions when we reach Glue and when we reach Spark. So I will explain the difference between Glue, EMR, and Spark.
Yeah. Thank you. Thank you.
Okay. Any further question? Any last question? I can take only one question now, guys. Okay, if there is no question, so I have a very small demo prepared on AWS itself. So what I have is I have a very small pipeline, which is handling the real-time streaming data. So it's a streaming data engineering pipeline, which means that it can handle real-time streaming data. It can extract it, transform it, and load it. And you will see that this is something I'll show you in real time, right? I'll produce one streaming record. This record will be processed in real time, and this record will be loaded back to a DB in real time within a click of one button, or say within a click of 1 second itself, right? So for that, let me quickly hover back to my AWS screen, right? So I'm using AWS, right? This is the main console of AWS. Need not to worry. All of this will be explained in detail as we move along in our sessions going forward. But to process this, I have for streaming data producer, I have a tool of AWS which is called SNS. For processing this data, I have a tool called Lambda function. And for loading this data, I have a tool called DynamoDB, which acts as a database. And all of these are AWS provided services in general, right? So I can quickly show you. So I have a database here. I have a table. So in this table, you see that there is only one record that I have loaded earlier. I am going to load new records in the same table, but with the streaming flow itself, which means that instantaneously, as soon as I produce new data, it will be loaded back to this table automatically. No human intervention required whatsoever, right? Let me head back to my SNS, right? So basically, I have a data, right? So I have a column called customer ID. Let's change it to something else. I have a customer name. Let's change to John Peter. And location, let's change to something else, right? This is one record, right? Let me copy that. Let me produce this record using SNS, right? I'll say sample message. I'll put the message. Everything looks fine, right? Customer ID is BBB. Customer name John Peter. Email is this. Location is this. Let me publish this message. So my message has been published. If you look closely at the message ID, this is the message ID. It ends with CCD, right? So there is my Lambda function, which automatically gets triggered, right? I haven't touched my Lambda. It's automatically gets triggered, and it should have processed the record by now. right? Let's see the logs of our Lambda function. So how can I see the logs of Lambda function? By going to the CloudWatch log, which is again is a service. We will see this service as well as we move along in our sessions, right? Let me head back to logs of Lambda. Okay. And I can see there is a log just 1 minute back, which has been generated, which means that this Lambda has been triggered automatically. Let's see what exactly is happening in the log. In the log, it says item has been added to DynamoDB, which means that our record should be added to DynamoDB, right? Uh, it means that Lambda has been successful, right? Let's hop onto our DynamoDB. Let's run the query and see whether the data has been loaded or not. And yes, I can see there is a new record which has been loaded to our database. Everything happens within a couple of seconds, right? No human intervention required. I just produce one record and every ETL has been taken care of by my Lambda, right? And which triggers automatically and process the data in real time within a few seconds itself, right? This is the record which has been added. Let's verify every information. The ID is BBB. Customer name is John Peter. Email is johnpeter@example.com and location is CA, which demonstrate a capability of real-time data streaming explorations or say ETL or data engineering pipeline. And guys, believe me, to build this pipeline, I would have only taken 10 or 15 minutes, not more than that. So within 10, 15 minutes, I was able to build this full pipeline end to end, and I was able to process this data. And guys, uh, something I can assure you that after the end of the sessions, you should also be able to build these pipeline with the same ease. So that's a quick, simple demo I have with me for today, considering the time constraints. Uh, I'll take a quick pause here to see if there is any question that is coming to your mind. Any question, no question is wrong. You can ask any question, guys.
Yes, I mean regarding the AWS Lambda, just I was the ETL developer, which I was using the Talent as a tool, right? So if I want to run the job, I mean if the batch files I have provided in the AWS Lambda, with this triggers like something you have mentioned, where I was not aware of the AWS Lambda, so it will automatically run the job. I mean trigger the job.
Yes, absolutely right. It will take
Uh,
care of processing the job. You can
uh,
automatically trigger it by uploading the file, or you can schedule it as per your own schedules. Everything is possible with Lambda. So it has all the flexibility.
oh, okay, yeah, thanks.
Thank you. Any other question, guys?
I have a question.
Yeah,
Is this course designed in a way that a layman can also understand the terms and language and everything? Because
very
I
good
don't have,
question.
yeah,
Very
sorry.
good question. No problem. No problem. So thank you for asking this question, first of all. And it's a very good question. Yes, the way we start is first we do an assessment of our uh, uh, capability on different tech stack, right? So we have a parameter. So at the first day itself, we check that our audience, our class is good at these many areas, and our class needs some push in these areas. So that I have a assessment of what our class expertise is. Once this has been identified, accordingly, we'll start the curriculum in a way that every person, as per the assessment we have done, can understood all the aspects of this course. So in short, yes, a layman can also understand all of these things.
Thank you.
Yep.
I have another question. How much deep we need to learn about the Python? Why? Because like I was not aware of these all things. So
Okay. Okay. That's a good question again. Python is something which we need to learn.
mhm.
That's one thing. And in terms of deep, if you know a basic of Python as well, that should be sufficient enough for our course, right? And still, if let's say you are struggling with basics, so we can cover the basics as well, depending upon how much the overall percentage of students need help with Python as well. This is something we can cover as well. And guys, basic itself is should be enough to go through this whole course. And Python is the language that data engineers uses in their day-to-day activity.
Okay.
Okay. I can take two more questions, guys.
I may ask another one. So, how, I mean, for example, as I have the experience in ATL and I want to move to data engineering, so how much, which I have to require, I mean, I need to get all knowledge of all this, whatever you mentioned, or yes, at least we can manage it based upon the AWS Glue and AWS Lambda or Python like that. I mean, like if I want to switch to data engineer and how much time it may take and I mean, like within a 2 months we can manage or how and after later on the interview parts how we can able to manage after. I mean we need to shift then we
Right,
as a experienced person we need to go back and submit which we need to manage. Is
right,
this enough for us to
right,
manage?
right. Good question. So the course is designed in a way that it covers the various aspects of data engineering that a data engineer can use in their day-to-day life, again with respect to AWS, right? So it covers Lambda, it covers S3, it covers Glue, it covers Spark, EMR, Redshift. So all the services we will cut across in this course. Coming from the interview standpoint, so whenever we'll discuss a service, we'll discuss the interview aspect of that service as well. Like what question that has been asked earlier, we'll talk about those questions as well as part of our sessions, right? In terms of how soon you can shift. So at the end of the course, you should be enabled with data engineering aspects. Now it's up to you how you grasp things and how you tackle future challenges.
Means how many experience I mean, after completing this of the course how like if I for example if I have finished all the course and something basics I have learned, but how many years of experience where I can able to gain, I mean with the help of this content which we have processed, I mean which we have learned everything.
Okay, so you should be able to start in your career with respect to data engineering, and whatever experience you have you can excel on top of that. So I don't have a right answer like how many years of experience I can tell that. For example, if there is a person with 2 years of experience and there will be person of 8 years experience as well in our course, so for them the right experience will be different after the end of this course, right? So but definitely you will be trained for AWS data engineering perspective. And once this has been done, you should be able to, handle data engineering projects for sure.
Yeah, thanks a lot.
One last question, guys, I can take.
So, just a quick question about what is the role of data engineer? What they do in day-to-day activities? What kind of work they perform?
Okay, good question. So a data engineer responsibility is to, in layman terms, extract data. Data can come from a file, data can come from a table, data can come from a streaming source, right? They need to build data pipelines that can transform the data. Transform means, adding more information, filtering some unnecessary data out, enhancing the quality of data. Once this has been done, finally loading the data back to a target. Target can be again a file. Target can again be a table. It can be a database. It can be a streaming source as well, right? There can be various targets as well. This is what in general a data engineer do. Then how they do it? It is something they do manually? No. Once they build a data pipeline, it runs automatically every day or whatever the schedule is. What they do is they build these pipelines that can extract data, transform it, and store it back to a target. How they do it? There are various methods. I showed you one method. For streaming use case, we have used SNS, we have used a combination of Lambda, we have used DynamoDB, right? So once this pipeline has been built, it can run automatically on autopilot without any human interventions. This is what data engineers do.
Okay, so basically ETL, you're talking about ETL, right? Extract, transform, load. That's all.
In simple words, yes, but ETL again is very complex if you have to deal large amount of data, let's say big data, if you have to deal streaming data, then there are various flavors of ETL that come into picture. But in short answer, yes, data engineers are responsible of managing data pipelines, and you can say it as ETL as well. But how you can do ETL, that is the most important tricky part.
When you perform ETL on cloud, then how does it matter whether it's a small data or big data? Because there is a auto scaling, so automatically it will scale up, right? According to your.
Very good.
So
Very good.
how it is complex.
Correct. So it can scale automatically, but it needs to know when to scale. It needs to know how to scale. It needs to know the cost, right? Where to use Lambda, where to use Glue, where to use EMR, where not to use S3 buckets, where we can use SQL database, where we will use NoSQL database, where we will use Redshift, right? So all of these things from a data engineering standpoint, we need to know, right? Your assumption is right. Cloud can handle small as well as large, but how? For cloud to handle, we data engineer configure everything in that fashion. So that is the, in layman term, what data engineers do as well. For streaming use case, there will be a different data engineering pattern. For batch processing, there will be a different data engineering pattern. That is something we data engineers needs to know as well.
And what are the NoSQL database in cloud, AWS cloud?
The one which I am just showing you is a NoSQL database. It's called DynamoDB. Okay. Any further question, guys?
No,
Dev,
I'm good.
Dev, Harish, Mallikarjun.
No, I am good. Thank you.
Aditya, I have one question.
Yes, please.
Actually, by using this glue, is it possible to process the complex data like struct type and everything?
Can you repeat the last word after complex? What word you have used?
Is it possible to process the data like if you have a complex data like struct type and array type? Is it possible to process by using glue?
Okay. If I heard you correct, you are saying that complex data type, which means that nested array list and all.
Yeah.
Is it
Correct.
right? Yeah, you can do that with slight modifications. Yes, you can do that.
Yeah.
Okay. Guys, thank you so much for your time today. It's been a wonderful session. Thank you for being such a sports audience. I hope to see you in our first sessions, which is going to happen soon. Ganesh will let you know all the different schedules and timelines. With that, I'll hand it over to back to you, Ganesh. Thank you so much again.
1 second, Aditya. Also, I just want to know about the timings as well. I'll ask like everyone what is their availability or what is their preferable timings, so that I'll check like a majority of the people timings and we can plan accordingly. So any Sneha, like what is the timings you're preferring?
So 9 a.m. in the morning suits me because I work in the afternoon shift, like afternoon to night shift.
Okay. And
Yeah.
Mallikarjun?
Yeah, even for me, yes, from afternoon 2 to 11, and it may go beyond that, and sometimes it may go to 4, 5, 3 or 4, 5. So I think it's fine for 9, even for me.